Hello students, today we are going to talk about inequalities involving absolute values. For all real number x and k which is greater than or equal to 0, we have two cases. Roman 1, absolute value of x which is less than or equal to k is equivalent to this inequality. Then Roman 2, absolute value of x which is greater than or equal to k is equivalent to those inequalities. And also you have given interval. For Roman 1 you have this interval here, and for Roman 2 have this. Now we have to show where those two expressions, where do they come from. Just to show this we need to use the definition of absolute value. Then remember that absolute value of x is equal to x if x is greater than or equal to 0, and it is equal to negative x if x is less than 0. Now on Roman 1 we have absolute value of x which is less than or equal to k. We have two cases. The first one is where x is less than or equal to k. The second one is where we have negative x which is less than or equal to k. Still, this one can be written as x which is greater than or equal to negative k. Just the sign is reversed because we're multiplying both sides by a negative number which is 1. And even this one can be written as negative k which is less than or equal to x. As you see now, we have two inequalities. We have this one and this one, so we need to combine them. At the end we get this one here with negative k which is less than or equal to x, and this x which is less than or equal to k. Roman 2, just we have absolute value of x which is greater than or equal to k. The first case is just where we have x which is greater than or equal to k. The second one you have negative x which is greater than or equal to k. Still now you have this one can be written as x which is less than or equal to negative k, because we are reversing the sign because we are multiplying both sides by negative 1. As you see, we have this inequality here and this one, and we are not able to combine them into one. Then conclusion is that absolute value of x which is greater than or equal to k is equivalent of, just to have x which is greater than or equal to k, or x which is less than or equal to negative k. Examples. Find the solution set of each of the following inequalities. 1. Absolute value of x is less than or equal to 4. Solution. Just we have absolute value of x which is less than or equal to 4. As you see, we are on case Roman 1. Remember that you have x. This one is equivalent. You have negative k. You have x, then you have k. Now, for this example here, k is equal to 4. Therefore, absolute value of x which is less than or equal to 4 is equivalent. You have negative 4. X, then you have 4. Can present it on number line. Now you have 0, 1, 2, 3, 4 plus infinity. You have negative 1 here, negative 2, negative 3, negative 4. Here is negative infinity. Now as you see, x is between negative 4 and 4. Just you have close the circle since you have an equal sign. Close the circle, then the solution set is here. Now lastly we need to write down the solution set S, which is equal to, now we have an interval from -4 to 4. Example number 2. We have absolute value of 3x minus 15, which is less than 3. Solution of 3x minus 15. Still we are on this Roman 1. Just so we know that absolute value of x, which is less than k, is equivalent. Or just here have negative k. Have x, then you have k. Now, in our example here, k is equal to -3. Then we need to replace x by 3x minus 15. Then we get here 3x minus 15 less than 3 is equivalent. We have -3 less than 3x minus 15 less than 3. Since we need x here, then as you see here we have -15. We're going to add to all sides by 15. Now we get 15 minus 3, which is less than 3x less than 3 plus 15. 15 minus 3 is 12. Then now we get 3x. 3 plus 15 is 18. Now we're going to divide all sides by 3. Then at the end we get, here we get 4, which is less than x, less than 6. Still, as you see, x is between 4 and 3. Then the solution set S is equal to, have an interval 4 to 6 excluded. Example number 3. Have absolute value of x minus 3, which is greater than or equal to 1. Solution, just we have x minus 3, which is greater than or equal to 1. Now we are on case Roman 2, where we have absolute value of x, which is greater than or equal to k. We have seen that it is equivalent to x, which is greater than or equal to k, or x, which is less than or equal to -k. Now, in our example here, k is equal to 1. Now, we replace this x here by x minus 3. We have x minus 3 greater than or equal to 1 is equivalent of x minus 3, which is greater than or equal to k, which is 1, or we have x, which is less than or equal to -1. No, x minus 3 here. Then here we have, we take this -3 in the second side, then we get x, which is greater than 4, or x, which is greater than, we take -3 in the second side, we get 3 minus 1, which is less than 2. Now, let's say not equal to 2. We can make a number line. I will have 2, 4, have 0 here, 1, 2, 3, 4, 5, then it is plus infinity here. Here I have negative infinity. Now we have x, which is greater than or equal to 4. I've closed the circle here, then our solution should be here. And here we have x, which is less than or equal to 2. While moving from 2 to negative infinity. Now our solution set is equals to, we have an interval moving from negative infinity to 2 union 4 2 plus infinity. Example number 4. We have absolute value of 5x plus 6 plus 4 is less than 1. Solution, just we have 5x plus 6 plus 4, which is less than 1. You see, we need to solve for x. First of all, I have to take this from the second side, then we get absolute value of 5x plus 6, which is less than negative 4 plus 1. Then we get 5x plus 6, which is less than negative 3. Now, we have seen that the absolute value of any number is always positive, which means that if we replace x by any real number here, then this absolute value is positive. Now, this one is always positive, and you have our inequality sign. Negative 3 is negative. Then you ask ourselves a question. Is a positive value less than a negative value? The statement is not true. Just it is false. Reason why, for this inequality, there is no solution. There is no solution. So, S is equal to an empty set. Now you have exercises. Solve each of the following inequalities and represent the solution sent on a number line. You have exercise number 1, number 2, and number 3. Thank you very much.